This is Unit 8, Lesson B, Solving System of Equations by Graphing. After this lesson, you should be able to graph two linear equations on the same grid to find the solution, determine if there is one, none, or infinite solutions. So take a look at the graphs below, and I want you to try and think about what we said was the solution to those graphs, and think if you can come up with the solution. A solution is where the graphs cross. So I'm going to go ahead and find the coordinates of where they cross. And I don't really have a whole lot of grid lines, but I think I can see it here. It's at -1 and -1. So that's our answer to the first one. Again, a solution is where the two lines cross. This is looking like it's 2 and 2. Now, if you take a look, how many solutions do each of those have? They had one solution. So if they had one solution, are they parallel? That means no solutions. Are they coincident? That means infinite solutions. Right? Exact same line. So now we're down to being perpendicular or IBNP. Perpendicular kind of has a perfect X to it, where no matter how I draw it, I could always have a right angle in that corner. So if you notice, neither of these look like they could have a right angle, which actually makes both of those lines IBNP. Pause the video now as you try this clicker question. Press play to go over the answer. So we find ourselves right down here, which is at 2, -2. So now we're going to talk about how to solve a system of equations by graphing. We're first going to make sure both equations are in slope-intercept form. That's y = mx + b. We're then going to graph the first equation. Remember, you begin with b and you move like slope. We're then going to graph the second equation on the same grid. So on the same grid. So I have one graph with two lines drawn on it. And of course, find the point where they cross, the two graphs cross, and that'll be your solution. So this is to find our solution. It's the point where the two lines cross. Pause the video now as you graph both the first and the second equation of this system of equations. For the first one, m = -1. I'm going to make it a fraction by putting 1 over it. My y-intercept is -2. I begin with b. I move like slope, which means I move down and to the right. Down one, right one, down one, right one, and you keep doing that until you have a beautiful line. Now, you don't have to make it go all the way across. I like to, but sometimes you can just wait and see where the two lines look on the graph and then make sure you have all the points where you need them to be. Now, for the second one, our slope is 2/3. No need to make that a fraction as it already is. My y-intercept is 3. Oh, I forgot. The last step in graphing is to connect those dots. So I'm going to begin with my b at +3. And my slope is 2/3. So I'm going to go up to right 3. Up to right 3. Up to right 3. And what I notice is this isn't getting me to where they cross. So I'm going to have to do the opposite, which is down to left 3. Down to left 3, cha-ching, down to left 3. And as you can see, that is the point where those lines cross. So for our final answer, we're going to write down that coordinate. It's left 3, so it's -3. It's up 1, so it's +1. So my solution to this system of equations is -3, 1. Pause the video now as you graph and find the solution for example 4. Press play to go over your answers. Make sure you're pausing and actually trying the problems. That's the best way to learn. Slope is 1. Make it a fraction. Y-intercept is -2. Go down to -2. Up 1 over 1. Up 1 over 1. Down 1 over 1. Down 1 over 1. There is our first line. Second, slope is -2. Make it a fraction. Y-intercept is 1. I go to +1. -2 tells me to go down and to the right. Down to right 1, down to right 1. And luckily, right away, they crossed. Our solution is the point where they cross, which is right 1 for a positive 1, down 1 for a negative 1. So our solution is 1, negative 1. That's the point where the two lines cross for this system of equations. Try example 5. Press play to go over your answer. Notice I can't graph these until they're solved for y. So this top one, negative 2y, equals, I have to subtract x on both sides. Y equals, I'm dividing both sides by a negative 2. And there we are. Next, I have to solve this one for y, so I'm going to subtract that 3x. And then I'm going to divide by 4. Y equals negative 3/4 x plus 2. So then we check it out. I'm going to graph the green equation, the top equation first, at negative 3. Up 1, right 2, up 1, right 2. Do one backwards. Another one backwards. Make sure I got plenty of points there. Then I'm going to do the red one, the bottom equation. Positive 2. My slope is negative 3/4, so that's down 3, right 4. Oh, and luckily they crossed right away. So if I go ahead and I take a look at the value of the coordinate where they cross, 1, 2, 3, 4 right, which is positive 4, down 1, which is negative 1. So the solution to this system is 4, negative 1. Pause the video now as you try example 6. Press play to go over your answer. We're plotting it at 3. I go up to right 1, up to right 1, down to left 1, down to left 1. That's our first equation. Then we do this one again, but we're starting at negative 4. Up to right 1, up to right 1, up to right 1. Uh-oh. This is kind of weird. They are not crossing. Well, what do you notice about those equations? They have the same what? Hopefully you notice they have the same slope. If they have the same slope, then they're considered parallel. Parallel lines never cross. So if they asked you to find the solution, you would write no solution. And you could really tell that right away from our first lesson we had just by knowing that these had the same slope. Same slope, parallel, no solution. Pause the video now as you try example 7. Press play to go over your answer. So I'm going to graph this first one. It's at 3. My slope I'm going to make over 1, so it's up to right 1, up to right 1, just like the equation on the other page. Make sure it covers the full thing. Don't always have to do that, but I like to make sure that my lines cross nicely. Then I'm going to solve the second one for y. So I'm going to subtract 6x. Negative 3y equals negative 6x plus 9. Divide by negative 3. Y equals, that's going to make a positive 2x. Oh, forgot to divide this by negative 3. So it's positive 2x minus 3. So then I'm going to go ahead and plot it. 1, 2, 3. Up to right 1, up to right 1, up to right 1. What do we see? We have again, these are parallel lines. Now here's the cool thing. Let's say, for example, I had changed that to be a positive 3. And then let's say it was a positive because this was a negative. So I'm just changing the signs around. What that would end up doing is making this a positive 3. And then that, notice, would have been the exact same line as this guy up here. When everything's are the exact same line, that's when you would consider them coincident. When they're exactly the same. But because these weren't exactly the same, because this was a negative, that's why they end up being parallel, which is no solution. This brings us to our end of our lesson. If you have any questions, make sure to raise your hand, begin working on the worksheet, and have a wonderful day.